For sure, you have used the word heat many times in your life. You've experienced it. You have observed its effect. In your earlier grade levels, you learned that heat moves from source to other objects or places. Example is the kettle with water placed on top of burning stove. The water gets hot because heat from the burning stove is transferred to it. But have you ever wondered what it really is? How is heat transferred between objects or places? What are the three modes of heat transfer? To answer these questions, let us infer the conditions necessary for heat transfer to occur. Before we begin, let us first describe what thermal energy and heat are. Any object is said to possess thermal energy due to the movement of its particles. But how is heat related to thermal energy? Like any other forms of energy, thermal energy can be transformed into other forms or transferred to other objects or places. Heat is a form of energy that refers to the thermal energy that is in transit or in the process of being transferred. It stops to become heat when the transfer stops. After the energy is transferred, say to another object, it may again become thermal energy or may be transformed to other forms, thus satisfying the law of conservation of energy, where energy can neither be created nor destroyed. This time, let us do the simple experiment entitled Warming Up, Cool Me Down, to describe the condition necessary for heat transfer to take place and trace the direction in which heat is transferred. First, let us prepare the following materials: 2 small beakers, 2 small bowls which are enough to accommodate the beakers, tap water, hot water, and the laboratory thermometer. Assign the 2 small bowls as A and B, while beakers as 1 and 2. Half fill 1, 2, and A with tap water. While half-fill container B with hot water. Be careful when you pour hot water into the container. Measure the initial temperature of water in each of the 4 containers. Take note of the initial temperature of each container and write it in a piece of paper. Carefully place beaker 1 inside bowl A. This will be our setup 1. Place also beaker 2 inside bowl B. This will be your setup 2. Measure the temperature of water in all containers 2 minutes after arranging the setups. Record again your measurements in the table. Continue to measure and record the temperature of water after 4, 6, 8, and 10 minutes. Write all your measurements in the table. In which setup did you find changes in the temperature of water inside the containers? Right, it is setup 2. In which setup did you not find changes in temperature of water inside the containers? Correct, it's setup 1. Which container contains water with higher initial temperature? Right, it's bowl B. What happens to its temperature after 2 minutes? As we can see here in the table, the temperature of the water decreases. Which containers contain water with lower initial temperature? Correct, they are beakers 1, 2, and container A. They did not change at all. However, in setup B, the temperature of water in cup 2 and container B changed. What happens to the temperature of water in each container after 4, 6, 8, and 10 minutes? You may say that the temperature of the water in setup A does not change at all. But in setup B, the temperature of water in bowl B decreases, while that in beaker B started to increase until such time that their temperatures are almost the same. What does this tell us about the heat transfer taking place between the containers? Great! The condition that is necessary for heat transfer to occur is that two objects must have different temperature. Heat always flows from hot to cold object until such time that their temperatures are the same. There are 3 modes of heat transfer, namely conduction, convection, and radiation. When you place a spoon to stir the cup with hot coffee, the spoon becomes hot. When you iron your clothes, heat is directly transferred from the iron to your clothes. In these examples, there is a direct contact between the source of heat and the object. This is what we call as conduction. This usually takes place in solids. Water boils as the temperature of molecules within the water increases and they slowly begin to move at a rapid rate upwards. A hot air balloon floats as the fire heats up the air inside the balloon, which makes it less dense than cool air, allowing the balloon to inflate and rise. These are good examples of convection, where heat is transferred in the fluid from a region of higher temperature to a region of lower temperature. Heating food in a microwave oven and feeling hot under the heat of the sun are examples of radiation, where heat is transferred from one body to another body without involving the molecules of the medium. Thus, this mode of heat transfer does not need a medium to be transferred. Let us summarize what you have learned in the lesson. Heat is a form of energy that refers to the thermal energy that is in transit or in the process of being transferred. It stops to become heat when the transfer stops. Following the law of conservation of energy, energy can neither be created nor destroyed. Thus, this heat is not lost but rather transferred into other forms. The factor or condition that is necessary for heat transfer to occur is that two objects must have different temperature. Remember that heat flows from hot to cold objects until such time that their temperatures are in equilibrium or the same. The 3 modes of heat transfer are conduction, convection, and radiation. Conduction happens when there is direct contact with each other, which usually takes place in solids. Convection happens when heat is transferred in the fluid from regions of higher to lower temperatures. Lastly, radiation happens when heat is transferred from one body to another body without involving the molecules of the medium. It does not depend on the medium. Now, let us apply what you have learned in the lesson. Heat transfer is evident everywhere around us. Look at the illustration below. This depicts several situations that involve heat transfer. Your task is to identify 3 situations in the drawing that involve any method of heat transfer. Label them 1, 2, and 3. Note that in your chosen situations, there could be more than one heat transfer taking place at the same time. Make your choices more specific by filling up the table beside it. Write a 2 to 5 sentence reflection at the end of the lesson. Please do not forget to subscribe to our YouTube channel, Math Cycle, like the videos, and hit the bell button for updates. I hope you learned today's lesson. On the next episode, we will describe the different types of charging processes. This is Sir Leonard, your science teacher. See you all next time.